exercise 9D, finding derivatives by rule. So we spent a fair bit of time finding derivatives using first principles, but there is a much easier way. And here we go. If we consider f of x equaling a multiplied by x to the power of n, then the derivative f prime of x is simply going to be equal to n, which was the power beforehand, multiplied by a, multiplied by x to the power of n minus 1. So all that happens here is that the power would come down to the front and would subtract 1 away from the power. If we look at taking the derivative of a constant, so f of x, the original function, is equal to c, then its derivative will be always equal to 0. And if f of x consists of various terms, then we can break it up and just take the derivative of each term in turn. So if f of x is equal to g of x plus h of x, then f prime of x is going to be equal to g prime of x plus h prime of x, where of course g prime of x and h prime of x are just the derivatives of the functions g of x and h of x. Often we write the original function and derivative in different formats. So here we can see f of x, and then the derivative of that is f prime of x. We can have y, and we can write its derivative as dy dx, and we can also have y, and we can write its derivative as y prime. Let's take a look at some examples. So here in problem 1, we've got y equaling 8, and of course 8 is a constant. So here we have y equals 8. The dy dx, the derivative of y, is equal to 0, because the derivative of any constant is equal to 0. In b, we have f prime of x equaling negative 6 multiplied by x to the power of 3. So our technique here is that we take the 3 and we bring it down. This is when we're working out the derivative, so it's 3. This little point here just means multiplication. We haven't lost that negative 6, we've got the negative 6 there, and that's multiplied by x to the power of 3 minus 1, taking away 1 from the power. 3 times negative 6 is negative 18, and we have x to the power of 2. So the derivative of f of x equaling negative 6 x to the power of 3 is equal to negative 18 x squared. In a similar example, we have f of x equaling 3x squared plus 4x plus 7. So we have 3 terms involving this. All we need to do is work out the derivative of each term and place them together. So f of x is equal to this, then f prime of x is going to be equal to, the 2 comes down, we've still got the 3, and it's x to the power of 2 minus 1, taking 1 away from the power. The next term, 4x, we need to take the derivative of that. If we think of x being to the power of 1, I just follow exactly the same steps. So my 1 would come down the front, I haven't lost my 4, and it's x to the power of 1 minus 0. And of course the last term, we've got 7, which is a constant, and the derivative of the constant is equal to 0. So tidying things up, 2 times 3 is 6, 2 take away 1 is 1, so we just have 6x, and of course 1 times 4 is 4, and x to the power of 1 minus 0 becomes x to the power of 0, and anything raised to the power of 0 is just 1, so it ends up being 4 times 1, which is just 4. So the derivative of 3x squared plus 4x plus 7 is equivalent to 6x plus 4. In this point, all we're saying is that it's really good to make sure that we express whatever our function is in the simplest way possible, preferably as a set of different terms. Let's take a look at a couple more examples. F of x is equal to 4 over 3 multiplied by x to the power of 5. What we want to do here is express it so that the x is up the top. To lift the x up to the top, we just need to take the negative of the power. So I can rewrite this as being 4 multiplied by x to the power of negative 5 over 3. I can also just write this so that it's 4/3 times x to the power of -5. In this format, I'm able to apply the basic rule which I've begun this little tutorial with. So the derivative, I had the -5 and that comes down. I multiply by 4/3, I haven't lost that at all. And it's multiplied by x to the power of whatever we had beforehand, subtracting 1 from that. So I do the multiplication, end up with -20 on 3, multiplied by x to the power of -6. This format is not surprising to us and fairly obvious, but what I'm interested in is expressing the answer so it has a positive power. So rather than leaving it as x to the power of -6, what I do is I take the x and bring it down to the bottom and write it as being +6. So the derivative of the original function is -20 over 3x to the power of 6. What we are considering here is a square root symbol, or the radical symbol to be more accurate. If I have x to the power of some p, if I'm after the qth root of that, then I can rewrite that as being x to the power of p over q. Let's see how this works. Here we have f of x equaling the square root of x cubed, and I'm interested in finding its derivative. The square root is the same thing as just saying the second root of something, so I can rewrite it as being the second root of x to the power of 3. Following this format, I can rewrite the x, so it's x to the power of 3 on 2. There's the 3, and that's up the top, and then whatever root I'm trying to take of the overall expression, and there it is there, 2. So I have it in this format, and now I'm able to find its derivative quite easy. The power comes down, I multiply it by x to whatever the original power was, take away 1. Of course, what I'm dealing with here is fractions, so 3 on 2 take away 1 is the same thing as 3 on 2 take away 2 on 2. So I end up with 3 on 2 multiplied by x to the power of a half, and I can rewrite x to the power of a half as being the square root of x. So I end up with 3 on 2 multiplied by the square root of x, and then finally I have it in this format. Let's see how that's applied here with problem 2. Find the square root of x. So in A, square root of x, I can rewrite it as being x to the power of a half. Its derivative, the half comes down, I multiply by x, and it's raised to the power of a half, take away 1. And we end up with a half x to the power of negative a half. And of course I can rewrite that negative power, so it's 1 over x to the power of a half, multiplying through, and we get 1 over 2 multiplied by x to the power of a half, and then finally 1 over 2 to the power of the square root of x. Taking a look at B, y equals 1 over 3x to the power of 5. Again, I want to bring the x up originally so it's in a format that I can easily work out the derivative. So I can write it as being 1/3 multiplied by x to the power of -5. Working out the derivative, the power comes down, so I have -5 multiplied by 1/3 x to the power of -6. So I just subtract 1 away from the power. Multiplying through, I get -5 on 3 multiplied by x to the power of -6. And I can rewrite that as being -5 over 3x to the power of 6. Taking a look at C, 1 over the third root of x to the power of 4. So I can rewrite that as being 1 over x to the power of 4, or raised to the power of 1/3. So 1 over x to the power of 4 on 3. And of course I want to write that so that the x is on the top, so it's x to the power of -4/3. Again, it's in a format that I can easily work out the derivative. So basically the -4/3 comes down, it's x to the power of the original power minus 1. this minus 1 could be written as negative 3 on 3. So end up with negative 4 on 3 multiplied by x to the power of negative 7 on 3. And I can write that as negative 4 over 3 lots of x to the power of 7 on 3. So I've just brought that x down, and I had to change the sign of the power. And going a little bit further, I recognise that the x to the power of 7 on 3 can be written as being the third root of x to the power of 7. So overall I end up with negative 4 over 3 lots of the third root of x to the power of 7. Okay, let's take a look at D here, which is a little bit more complicated. F of x is equal to 2x minus 5 over 3 lots of x to the power of negative 3 plus 1 over 3 lots of the square root of x. I just want to rewrite everything so that the x's are up the top. So I have 2x, which is no worries, minus 5/3 of x to the power of 3. So I've just lifted the x up and changed it to a positive power. Plus 1 over 3 lots of x to the half. So I've just got rid of the radical sign that was originally here. In my next line, the first two terms are all easy to understand. But finally, I bring the x up to the top, and I need to change the power, so it's x to the power of negative a half. In this stage, or at this stage, it's very easy for me to now work out its derivative just using the basic rule. So here's the derivative. Derivative of 2x is just 2, minus the power comes down, so there's the 3, multiplied by the 5/3, and then I subtract 1 away from the power, so instead of being to the power of 3, it's now to the power of 2. Looking at the last term and working out the derivative of that, the power is negative a half, so the negative half comes down, multiplied by the 1/3 still, I haven't lost it, and it's x to the power of the original minus 1. So the first two terms simplified to what you can see there, and then finally negative a half times 1/3 is negative 1/6, and we have x to the power of negative 3 on 2. In my next line, you can see that I've taken the x to the power of negative 3 on 2 and I've brought it down, written it as a positive power. In this line, you can see that I've broken up x to the power of 3 on 2, so it's x to the power of 3, all raised to the power of a half. And then finally, in that last term, I can rewrite it as being 6 lots of the square root of x to the power of 3. Not surprisingly, with our CAS calculator, it's very easy to work out the derivative of a function. If we consider the last question, the first part of the last question, we had to find the derivative of y equaling the square root of x, what we would put into our calculator would be this. We need to go to Menu, Calculus, and then Derivative. And what we want to write in here is we want d of the function over dx. So it's x is the variable that we're trying to work out there. So I'm putting x into that section. And then over here, I'm going to put in the right-hand side. So originally I had y equals the square root of x. So what I'm after is d of square root of x over dx. So just simply use the square root. And it's of x. And now all I need to do is hit enter. And you can see there that straight away my CAS calculator works it out for me. And it's 1 over 2 lots of the square root of x, which is exactly what was worked out by hand. And you can use that for all of the different functions that you're presented with. But please remember that on exam 1 you will be asked to work out the derivative of various functions by hand, so you need to know it. But it's a great way of checking, and certainly when you're working on exam 2 type questions, this is obviously a lot more efficient.